Number one on this activity says to write one word problem for 7 times 4 and another for 4 times 7 using our definition of multiplication. And then before determining the answers to the problems, discuss whether it would necessarily be obvious to a student that the answers are the same. So you could choose any multitude of story problems that you want to come up with here. And we did talk about 4 different models of multiplication, so you could potentially use any of those 4. I will tell you that sometimes when it's referred to the definition of multiplication, sometimes that refers to the most common or most used definition of multiplication, which is the repeated addition definition or the groups of objects. So if we meant that, and I didn't explicitly state that, but if we meant that, then you would use the groups of objects model to write your story problem. So it would be, I have this many groups of this many objects. How many total objects do I have, right? So that type of story problem. However, technically there are different definitions, so you could come up with different things. If you use the multiplicative comparison model, that would be good here as well. We have area of an array. It doesn't make for as interesting of a story problem, like just to say, hey, I have this rectangle with this length and this width. So if you're going to make that a story problem, I would make it like carpet, like you're recarpeting a room or you're painting a wall or something along those lines. So what I would maybe not want to see, we did the counting model, and the counting model, the order doesn't matter, right? So specifically on this one, they're wanting us to write 2 different story problems, one for 7 times 4 and another for 4 times 7. If you used a counting problem, like, I have 4 different pairs of pants to choose from and 7 different shoes to choose from, how many combinations? Technically, that story problem would work for both 7 times 4 and 4 times 7 because the order doesn't matter in counting problems. So I hope that you would avoid a counting problem for this particular example because we're trying to demonstrate 2 different problems for these 2 different things. So I'll talk about what I used. This is what I came up with. I just said Jill made 7 cakes and put 4 candles in each cake or on each cake. And so I could ask, how many candles does she need? So that's the one that I came up with, and you can see this one. So which one is this? Is this 7 times 4 or is this 4 times 7? So in this case, the groups would actually be the cakes, right? And then there are 4 candles in each group or on each cake, right? So that means this would be, this is the groups and this is the objects per group. So this would be 7 times 4, not 4 times 7, right? So this is a problem for 7 times 4. And so then when you write a second problem, I think it's important to consider here, like what you're doing, like if you're doing this to demonstrate something to students, are we just trying to demonstrate how you can have 2 very different problems? Or are you trying to get them to come up with the fact that the 2 answers are the same? Are you trying to get them to recognize that? So like when I did this, I kind of said, well, instead of focusing on like how different my story problems would be, I actually want to make them very similar and see maybe if students would catch on, right? So the one that I did for 4 times 7 was I just changed it and said Jill made 4 cakes and put 7 candles on each. So quite literally just switch the numbers. And again, I want to know how many candles does she need. So then before we answer this, so this one, of course, is, the first one was the 7 times 4, and then this one's the 4 times 7, right? So before we find an answer, it said to discuss whether it would necessarily be obvious to a student that the answers are the same. Now, I think that your answer to this is going to be very different depending on what story problems you wrote. So I think something like this would be like the most similar that you can make them, right? So if you basically just wrote two story problems where all you did was flip-flop the numbers, then, you know, that's probably the closest it's going to be to obvious. What do you think in terms of like, is that super obvious that it would be the same answers? I think it's more obvious than other things, but it might still not be obvious, right? So, yeah, I can write something down here, but keep in mind your response would be very different depending on what you wrote. I think even in this case, it might not be obvious that they have the same answers because like the number of cakes and candles are different, even though you just swap them, right? You know, you can imagine if you drew a picture of cakes and candles, it's totally different pictures, right? It's totally different pictures, versus, you know, 7 cakes drawn with 4 candles each versus 4 cakes drawn with 7 candles each. Even though I'm going to get the same answer, right? Even though I'm going to get 28 candles with each answer, right? So I'm going to go ahead and say here that it might not be obvious. You might expand on that too if you did something very different. So like maybe maybe your first problem was kind of like mine with, you know, objects and groups, right? And so maybe you did something like that. And then maybe for your second problem, you switched it and did a different model, right? So now it's Jill made 4 cakes and um, she made 7 times as many cakes the next time, right? So now you've got a multiplicative comparison problem, right? So the more different you make that problem, the less obvious it might be. So again, you might think like, what if my first problem was, you know, Joey has 7 transformers and Timmy has 4 times as many, right? Versus your next problem was I need to tile a floor that is 4 feet by 7 feet. How, you know, what's the area of the floor I need to tile? That would definitely not be as obvious that you're going to get the same answer, because technically the units are different as well.